All right, so let me know once you can see the screen.
Yep, I can see it.
All right, thanks. Thanks for the information. So again, welcome to Linux Basics Live. So this course we created so that you can get started with all the very important commands, but what are some of the basic commands. So for example, if you are going for certifications later, like Red Hat Certified System Administrator (RSCSA), and then later Red Hat Certified Engineer. So these things focus more on this basically advanced topics or more specific things, but there are many things which are common between different vendors or different distros of Linux. And these basic commands become very valuable into the day-to-day task of Linux. So we thought, okay, let's create a program where we can start with some of the very initial commands. But although they are basic, but they are very important. And also a little bit of networking at the end, a small project of creating a web server and hosting a website on that. So in this course, that's exactly what we're going to cover. So if we discuss the details of the course structure, it is pretty similar to what some of the other classes also we have. So we are going to have these sessions once a week, and these sessions will be 2 hours in the length. But again, it's a topic-driven course, so not time-driven. So sometimes it can be more, sometimes can be less, depending on the particular topic of the week. And this particular live course that we have is going to be 8 weeks. So the one that takes you all the way to RSC, the pre-recorded one, that is 52 weeks course. But this one, the live where we cover the basics and the little bit of networking, slightly advanced security and networking. So that is only 8 weeks, 8 live sessions basically. And this is a completely hands-on approach course. So what we are going to do is every week we are going to directly jump into the configuration. So we'll start with, of course, the Linux installation and see how exactly the partitions work. What are the different directory structures that we can use? What are the important directories that you need to have, and which directories you should actually use a separate partition, which will be a better idea or recommended method. So we'll start from that, and then we'll of course jump directly into configuration of the important commands that we will do. And we also divide them into different categories. So basic commands, and then of course the editors, and then we have security, and then we have networking. So right from the next week when we start the commands, we will see you will see that starting from installation and partitions and commands, we will immediately go into the practical mode. And for this course, software, OS images, and lab instructions, along with the solutions, are provided in the course. In the sense, labs I'm going to give you every week. I labs in the sense the PPTs, because in the PPTs we will have all the commands, their options, their arguments, their definitions, and examples, so that you can also practice the same things when you are doing it on your own. As I mentioned earlier, that it doesn't have that kind of a labs like you have in Cisco, but you need to practice those commands. So you need to have those syntax and structure with you after the class. So the PPTs that we use in the class, in the classes from next week onward, I will send you after the class so that you can also keep them as a record. OS images provided in the sense that I'll guide you which OSs we are going to use, because in Linux you can quickly get overwhelmed. There are so many distributions out there, and it becomes quite confusing which one to start with and which one to continue. And as far as the basics are concerned, you can actually use any of these, but we'll see exactly what are the differences right in the today's session, that which is distro will be the best to start with. And I'll guide you that how you can actually just download those images. So as a matter of fact, in our course, we are going to use one server side Linux distro and one client side, so that we can connect them, and then later when it comes to the networking part, we can actually have at least two devices to enable communication between them. And if we are setting up any kind of server like Apache server, web server, so from the other device we can access the web server and see if it's working or not, right? So for that purpose, we will need at least two images. But for the first part of the course, I would say even a single Linux image will be fine, because most of the commands we will be using on a single server. And then later we will actually enable communication by using or introducing networking. So these live Zoom sessions are recorded also, and you will get access to these recordings for lifetime, again, just like any other course. So there is a 52-week course that's recordings are also available, but this is a separate recording, which is a live session. And you can always go back to these recordings. Now, remember, the recordings might not be from our class. It may be from one of the previous live class, but the structure and the commands and the topics that we cover are going to be same, right? So you will not actually miss anything if you are recording, if you are watching the recording from one of the previous classes. And of course, you get the membership to the Facebook community group that we have, where you can ask questions and you can get answers, whether it is from for any other courses that you are doing or for the Linux questions as well. And as I mentioned already, you will have the lifetime access to recordings for this course. So, what exactly are we going to cover in this particular live course, the Linux Basics Live? So we'll start with the introduction to the Linux itself. What is Linux kernel? What are the different distros that we use? What do we mean by Linux distributions? What is the desktop environment or DE? And how does it actually make any difference between different kind of experiences that you can get on the GUI or graphical user interface of the Linux? We are also going to discuss about the Linux operating system partitions and directories. So this becomes very important because when you are installing the Linux and you want to manually control that how many partitions you will need and how many directories you will need. So this knowledge can become extremely useful because there are many important directories that are created in Linux, and these directories might need their own separate partitions for best performance. For example, all the user profiles that you want to keep, they are into the home directory, so it's better to have a separate dedicated partition for the home directory so that you can back it up every time. So your user data, important user data, is not lost in case if something happens to the server, right? Similarly, the boot partition is always supposed to be a separate partition. You also need to have a dedicated swap partition, which is used to which is used as a replacement or substitute for memory. So if you are out of memory, out of RAM, then some part of that swap partition can be used as RAM. Of course, the performance will be slightly degraded because it's actually not as fast as RAM, but can be used in that case. And this is the mandatory partition that you need to make. So of course, in Linux, you can leave it to the system also. Let it decide how many partitions it wants, and you will see that different distributions, they decide different number of partitions, but it's always good to do it manually as well so that we know exactly that what is the best practice basically to decide the number of partitions based on the directories, and that will be of course part of the Linux installation that we will also learn. And in the same installation part, you will also learn the concept of file system, because when you are creating partitions, you always need to decide a file system for that partition. Now, you are coming from MCSC background, you know that in Microsoft, we use the NTFS partition, or there used to be FAT16, FAT32 partitions before, or file systems basically. And these file systems dictate, the structure of your partitions, like how many files you can create, what can be the biggest size of a single file, what can be the naming structure you can use, how long the name can be of a single file. So these kind of things are actually decided by the file system of the partition. And we'll see that in Linux, it uses slightly different file systems compared to Windows. So we have ext2, ext3, ext4, there is XFS, there's BTRFS. So what are the differences between these? What are the pros and cons of using one over the other? Which is very important to start using Linux. So this is something we are going to learn as well. And then, of course, introduction to the CLI and basic commands. Now, although it is a single line, but we will have actually many sessions on the basic commands, because there are many very, very useful basic commands in Linux, which can be extremely useful and extremely interesting also to start understanding how exactly the CLI interacts with the kernel, how actually you can achieve some certain things, and how powerful CLI is. Because, for example, a simple find command that can be used to find any directory or file can become extremely powerful when you associate it with some certain arguments. For example, you want to find all the commands which have the keyword user, and you want to delete those. So you can directly do it with a single command. You just don't find it, but you can also delete those. Or maybe you just want to rename those files with something else. You can do that with a single command. So these powerful, seemingly simple commands, but really powerful commands that will give you a real insight into how Linux work. And of course, gives us a lot more confidence and comfort level with the Linux to start going into the more specific or more certification specific journey later when we want to go for RSCSA and RSC. We're also going to discuss about a very important aspect of Linux, which is package manager. So package manager is basically the used for installing the softwares in Linux. And in Linux, the softwares are called packages because they are packages, means there are many files into these packages, which are used like library files, or the executable files which create a package, and how do you install the packages, how do you upgrade the packages, delete the packages, basically softwares, how do you install softwares in Linux. Now, Linux has improved a lot in last 10 to 15 years, where the GUI is becoming more and more easy to use and less error prone, I would say, less buggy. So you can use GUI also to install many of things nowadays, but CLI also has a very powerful tool for installing packages. Now, this is where you will see most of the distros differ significantly, because it depends on which line of Linux distribution they are following. So there are many different Linux distributions. There are actually literally more than 1,000 Linux distributions are active currently, but you will see most of them actually follow either the Debian-based Linux distribution system or package management system, or the Red Hat-based package management system. So Red Hat-based will always use the DNF command, or earlier it used to be yum command, yum install. But if it is Debian-based Linux or following the Debian line, then they use apt command or apt command, apt upgrade, apt install, and for example would be Ubuntu or Linux Mint. These Linux operating systems, they actually are Debian based, right? Versus if you use Fedora or Red Hat Enterprise Linux or Rocky Linux, Alma Linux, they are actually from the line of Red Hat Enterprise Linux, or you can call it the RHEL, which used to be the short name for RHEL, right? So we'll see the differences between package management and how we can do it in some of the important distros. And as I mentioned earlier, introduction to the Linux file system, we will understand in detail the differences between these different file systems, ext4 versus XFS versus BTRFS. What are the pros and cons? You will see that in some file systems, you can increase the partition size, you can increase the partition size while the partition is online, versus some others cannot do it online. So you have to take the partition offline, and then you can squeeze or increase the size of the partition. In some other file systems, you can only increase or extend the size of the partition. You cannot squeeze it back. You cannot reduce it. So we'll see the differences or the pros and cons between Linux file systems, which can be extremely useful in future when you go for further implementation. In this part, we are also going to understand, although it's a slightly advanced topic, not part of the basics, but we are still going to discuss the logic of it, which is called the LVM, Logical Volume Manager, which is a very interesting concept in Linux. You will see where you can actually combine multiple physical hard disk drives into a single logical volume. And then you can actually divide that volume group, and then you can divide that volume group into different volumes. Volumes are basically logical partitions. So generally, traditionally, we learn that a physical drive can be partitioned, right? But if you have two different drives, you cannot combine them. But here in Logical Volume Manager, you can actually do that as well. And you can create a partition which is spanning multiple hard disk drives as well. So that is a very interesting concept that we are going to understand the logic of it here in this course. But in the 52 weeks course, you have the complete configuration and management of that LVM as well, right? Now, we are not only going to keep this course to basics, although we do mention that it is the basic command course, but we are going to understand some advanced stuff as well, like creating users and groups, and what is the importance of the root user account, and how do you elevate privileges for a normal user account to perform some tasks which need administrative privileges, and what is the importance of creating more user accounts, and what is the importance of grouping them together in different types of groups like contractors, employers, or Internet of Things devices, IoT users, or guests. So why do we need these groups? What is the benefit of that? And this will actually pave the way for a even more advanced topic, the file and directory permissions. So this is actually a security implementation. You can also call it authorization, right? So users and groups help you to authenticate any individual. So you want to prove the identity. So if I am saying I am Arpit, I need to prove it. So I need to have a password or some kind of unique identity that will prove beyond any doubt that I am actually Arpit and I am logging in. So authentication is verifying the identity, and that's where the users and groups are very useful, right? On the other hand, permissions is authorization. Authorization means I already know that you are Arpit, I already know you are Lee, but what exactly can you do? What level of access are you going to get? That is something I'm going to control by permission. So that is called authorization. So authentication is verifying the identity, And authorization is configuring the level of access that you are going to get, right? So that is something decided by file and directory permissions. So permissions is a very interesting concept, and we will see some basic permissions and advanced permissions also, like what exactly is the concept of set user ID or set group ID. What exactly happens when we do that? There is a T bit also we can set, which is very interesting concept. So we'll see all these things into the permissions part, of course, with some practical examples as well. Now, any basic Linux implementation cannot, or any basic Linux implementation topic cannot be finished without talking about the editors, because you are talking about CLI, and most of the times you need to deal with files. There is a very common saying in Linux that everything is a file, right? In Linux, every single thing is a file. Every setting is also a file. Every device is also a file. And of course, the configurations are also inside files. So most of the times when you are setting up servers, or you are creating, you're installing softwares and you want to tweak some settings, you always have to open files and change the configuration. So to change the configuration of files, we need editors. Like in Windows, we have the GUI editor, Notepad. In Linux, you have GUI editors as well, as well as you have CLI editors. So, for example, Nano and VI, these are the examples of CLI editors that you can use. Where VI is a very, very powerful, but a very raw editor, where it has a learning curve. You need to learn few things for VI editor to be used, which is called the visual editor. But once you learn those, many people actually prefer to use VI because they become so proficient with just the keyboard commands that they can modify the text or actually manipulate the strings much faster than GUI or using any simpler editor like Nano. And there are other editors also like gedit and Emacs, which have a specific use purpose. Like Emacs can be used for programmability, and it has a very nice syntax for that. So there are some other examples also that we will take, but mostly we are going to concentrate on Nano and VI. And then we are going to top it off with the networking basics and how exactly we can connect two different Linux servers together, so that we can finally do our project. Once the course comes to the end, we will do a project of Linux web server. We will use Apache web server implementation, how we can activate HTTP and HTTPS so that somebody can connect with or without encryption to our server and can get a web page or multiple web pages or many files that can be access from any browser, as long as there is a reachability to the system, right? So these are the things we are going to cover into this basic course, which will going to set you up very well for expediting your preparation for RSCSA and further for RSCE as well, right? So this is the basic part what we are going to. Now, what tools are we going to use? So of course, if you have some spare uh, physical devices, physical servers or computers, you can install Linux directly on those as well to practice it. But mostly you don't need to do it. You can actually use VMware Workstation Player, and you can install the individual Linux operating system directly into the VMware using their ISO files, right? So I'm going to send you a file, a PDF file after the class, which is basically which Linux OS you can download and the links to download them. Although it's of course open source and it is available online, you can just do a quick Google search and you can find any Linux operating system there. But what exactly are we going to use in this class? So as I mentioned earlier, that there are two main Linux distro families, Debian based. So they use the apt package manager, and Red Hat based, which uses the DNF package manager, Yum package manager. So you will see that there are some differences here, but when it comes to the basic commands or the core commands, they are still using the Linux kernel. They are based on Linux kernel. So it's going to be same in both cases. And that's why you cannot go wrong with any of the solutions. So whatever I'm saying you in this document is just a recommendation. So you can use a different Linux operating system as well. It is completely fine. For example, for server side, I would recommend to either use directly the Red Hat Enterprise Linux. Version 9 or the latest version 10 is also out, so you can use that one. And you can go to this link to download it, or you can use the Rocky Linux. Now, the issue with RHEL is that although Linux cannot be sold, it's a open source software, but they do sell the support, right? So this is an enterprise Linux, so it comes with support. So unless you purchase the support, you have to use a developer edition. So developer edition is free. I think up to 16 devices can be licensed. So there's an issue with the licensing with RHEL 9. So if you download RHEL 9 or RHEL 10, you will see there's a subscription manager, and you need to register your Linux copy online, or you need to delete the subscription manager so that you can start using it without any subscription as well. So there are a few steps you need to take before you can start downloading packages and installing them in RHEL 9. Instead, I would recommend to use Rocky Linux, because Rocky Linux is actually an open source enterprise, completely open source, designed to be 100% bug for bug compatible with RHEL 9. So RHEL 9 or RHEL 10, whatever is the latest version. So you will see that Rocky Linux is exact replica of Red Hat Enterprise Linux. That's why whatever commands you see in RHEL 9 or RHEL 10, you will see into the Rocky Linux 9 and Rocky Linux 10 as well. And it is completely free, so it doesn't need any subscription. It doesn't need any activation of the license. And right off the gate, once you install it, you will be able to use it forever freely, right? So there is no headache of registration and all these things in Rocky Linux. And you get exactly same operating system as RHEL 9. So you are not going to miss anything if you are preparing for CSA or if you are preparing for RSC. Although there is another one also which is called Alma Linux, which is also pretty similar to RHEL because it is also based on RHEL. But we skipped here because it's pretty similar to Rocky Linux. So you can actually go for Rocky or Alma. But you can go with Alma as well. Alma Linux is also free. So you can use Rocky or Alma. These are the two options we have. For the client side,
Just before you move on, just for the
yeah,
Rocky Linux, which ISO do we download? Is it the boot ISO or the DVD?
the DVD is okay because then we will make it bootable using the normal Linux VMware installation. So
Okay.
you can download the DVD ISO basically.
Okay, thanks.
So for the client side, you can either use Fedora. So this is Red Hat based, or you can use Linux Mint or Ubuntu also, which is basically Debian based operating systems. So again, we will be using it when it comes to networking part, when we will use two devices. So one will be client who will be just connecting to the server and connecting to the web server that we will implement. So again, you can't go wrong. Or even if you're using something else, like if you tell me, hey, I already installed Ubuntu or I already have Pop OS, can I use that? Absolutely. That is absolutely no problem at all. Again, these are just the recommendations. Fedora is in-house. So if your server is Red Hat Enterprise, Fedora is also actually Red Hat, and it is actually, you will see is the upstream to RHEL or CentOS stream. So what happens is that it's the hotbed of all kind of testing. So they test all the latest features in Fedora, and then only the features which are stable and working well, they go to the CentOS stream, and then from there, the certified stable features, they go to the next release of Red Hat Enterprise Linux, which is the enterprise version which they sell support for to the organizations. So it's a three-step procedure. Fedora's features are filtered and only better features go to the CentOS stream. And the best features from CentOS stream go to the Red Hat Enterprise Linux, right? So Fedora can also be definitely a good client-side product. Linux Mint is more like Windows 11 because it is highly GUI based and there are so many codec support. So you can directly right off the bat you can start watching videos, and most of the GUI server drivers are also supported. So it feels like Windows 11, and it's more like end user experience. So if you are recently moving to Linux and you just want to use it as a daily driver instead of Windows, then most of the people actually go for Linux Mint or Pop OS, which is another Ubuntu variation, right? So that can be good. But Fedora is not so GUI friendly. It is GUI, but it's not as good Linux Mint. So some of the features might be missing, and you may have to install them separately. But again, our objective here is not to have a end user experience. Our objective here is to have services and networking configured. Now, having said that, I'm calling them client, but in Linux there is no concept of server or client. The concept is that which services are you installing. For example, in Windows, what happens if you have a Windows 7 or Windows 11 Home Edition? You cannot make it a domain controller, right? Because that is not allowed, and you cannot use the group policies there. But in Linux, it's no such thing. It's the same kernel, whether it is Linux Mint or Red Hat Enterprise Linux. So you can actually configure Red Hat Enterprise Linux as the client, and Linux Mint can have all the services installed like web services, DNS, DHCP, or database services, and it can become the server. So it is completely possible. It depends on what services you are installing, right? So it's there is no logic of server or client as far as the Linux is concerned. So you when you go to this website, you can see that, for example, RHEL, you can download it at no cost, but then you will have to activate the subscription. And if you're going for Rocky Linux, you can actually click on the DVD ISO. So you can go with Rocky Linux 10 or Rocky Linux 9. Both are actually pretty solid. So any one of these is okay. And the DVD ISO has the complete feature, right? And Linux Mint, you can go with Cinnamon Edition. Cinnamon Edition is pretty good. Basically, it is the desktop environment, the front end GUI, which is slightly different. XFC is a lightweight edition, so if you have less RAM, less processing power, you can actually go with XFC or Matte Edition. So Matte is actually a classic desktop environment. It will give you the Windows feel completely because it is like a start button and everything is like that, right? Cinnamon is the best if you are trying to download the Linux Mint. If you are going for Fedora, you can download the whatever the latest Fedora version is. Fedora is very frequently updated every time, so you can't go wrong with any version of Fedora that you want to download. So once you download the ISO, you actually go to the VMware and then you are going to start installing regularly. So next week we are going to start the installation part, and then we'll see how exactly it can be done. So this week you can just download the ISOs and keep them ready for the next week class. Uh, but in VMware, once you select the ISO, make sure that the network type is set to NAT, and that way you will be able to connect to your host device as well to enable communication. And maybe if you want to check if your web server is properly configured, you can even access that from your host Windows machine as well if it is set to NAT, right? And this will allow the Linux and the host machine to communicate. And for most of the part, we are going to use only one Linux machine for the basic commands, but later we will have two machines for the networking part, server and the client. And although VMware is the recommended setting, but if in case if you decide to use VirtualBox, which is another solution, Oracle's VirtualBox for virtualization, then make sure that you use the bridged mode for the networking, and that is a better option in case of VirtualBox. But for VMware, net option for the network interface is what I recommend to use. So you can see once you set the network adapter to net, make sure that you give enough RAM. I would recommend to give at least 8 gig, although it shows 4 gig here. But the reason is because most of the distros that we see nowadays, they do come with GUI by default. And whenever you have GUI, it does take a little bit more resources. Like most of our course, we will be concentrating only on the CLI. Only some parts we will do in GUI. So technically, you don't need GUI that much, but it's always good to have experience of how many different types of graphical user interface we have. For example, what is the difference between Genome and K-Desktop or XFC, is different kind of desktop environment implementation. So it's always good to give at least 8 gig of RAM. And processor, I would recommend to keep it 2, because I have seen that if you give more processors, because it's a virtualized environment, the Linux start behaving a little bit strange. Like sometimes the GUI doesn't load properly, and you might have some issues in that. So the keeping processors to only 2, no matter how many actually you have, will be a good idea.
By the way, once you've configured these, can you change them? So I remember you talking
Yes,
about the
yes,
partitions and stuff like this.
absolutely, absolutely.
Okay, yeah.
So the only thing is that some things you can change while the device is still running. Like you can change the memory while it is running, but some other things like if you want to change the number of processors or network type, then you may have to shut down the device first.
Yeah,
That's the
because
only thing.
I've actually done the installations already. I did the Red Hat one. I don't know, I can't remember, sometime this week. On my
Okay,
Mac, and then I've got I did the Mint one.
Linux Mint. Okay,
Yeah, I've installed that as well as Fedora, which but I haven't actually looked at Fedora yet. But it's just it is there, so it's
okay,
I still have to install it locally. But I did allocate. It gives you like a default allocation of about 20 gig when you're doing the install.
right.
I noted in your video that you actually pulled it up to about 100 gig. So I'm guessing this is probably the way to go. With all, is that with all the installs or
No, actually, I was going a little bit overboard, to be honest,
okay?
because in real implementations, yes, you will need more storage because you're talking
Yeah,
about the hard disk drive, right? The storage.
yeah, correct, correct.
So, for most of the practicals that we are going to do in this live class,
Yeah.
20 gig is actually enough. You don't need to worry about more. The reason I actually change it to 100 gig because in the installation session that we will do next week, I'm
Yeah.
going to make multiple partitions, and then it's better to have a little bit more space so that you can partition
Okay.
them, right? That was
Okay.
the reason
Okay.
why I use more.
Okay. Yeah, I
And
actually did it
anyway,
sorry, I actually
you
did
can
it
also,
in the Red
yeah,
Hat
go ahead.
server, the actual Red Hat the install that I did on the Mac. That's the only one where I made it a 20 gig. So that should
Got
be
it.
fine in terms of just increasing that. That's okay.
Yeah, you can increase that also. That's not a problem. And anyway, you can install it again in VMware because the more practice you have with the partitioning, we will learn as well. So it will anyway will be a good thing. You
So
can
we can
install a
also
new
change the
copy as well.
processes as well because I made it 4 instead of 2. So can we
So
change that
if
as well?
Yeah, but in case if you boot the device and if you see that it is working fine, then it's okay. I just meant that sometimes it becomes a little bit like GUI doesn't load properly. So that
Okay.
time you can play with the number of processors and then see if it makes any difference.
Okay, no problem.
Otherwise, if it is working fine, then you don't need to touch it. It's fine, right?
Okay, no worries. Thank you.
All right. So now let's talk about a little bit about the Linux that we are going to cover. So next week we are going to start with installation. But first of all, let's talk about what exactly Linux is. So it's actually a family of free and open source operating systems based on the Linux kernel. So Linux kernel was created by Linus Torvald, and this kernel has been used by many different implementation of Linux, which we call the distributions, right? So these are called Linux distributions or Linux distros, which are based on the Linux kernel. So it was initially created in 1991 by Linus Torvalds. So what interesting story is that Linus was using Unix in his office or in his work, but Unix was of course a paid operating system. You need to purchase it. You had to license it. So when he wanted to do something at his home setup, he could not use Unix because you need to purchase it. And he thought, okay, we need to create something which is open to everyone, and we don't need to purchase it. So he started creating the concept of Linux. So it's that's the main USP of Linux. It's a free and open source operating system, and the source code can be modified and distributed to anyone, commercially or non-commercially, under the GNU public general public license. So this general public license or GPL actually mentions that you cannot sell the operating system itself, but you can sell around it. For example, you see Red Hat Enterprise Linux, they are selling the support for it, right? Or some special features if you are selling apart from the main operating system, you can do that. Some subscription, some services, you can do that. But the kernel or the distro that you created based on the Linux, you cannot actually sell it because that is under the open source GPL license. So initially, Linux was actually created for personal computer. That's the funny thing because that's what Linus wanted to use it for his own personal computer. But of course, it became the biggest server implementation in the world now. Everywhere, Linux is used for the backend servers because it is extremely stable and hardly anything goes wrong once it is properly set up and it starts working. Mostly, people keep the server side CLI only because the GUI gimmick they don't need. This is only for the end users. So mostly you will see the servers are also using only CLI. That also saves a lot of resources as well, right? You don't need so much RAM to load the GUI every time. But of course, initially it was meant for the personal computers, but later it was used for other machines also, like servers, mainframes, computers, supercomputers, and you will see that nowadays Linux is used everywhere, in even in embedded systems like routers, automation controls, TVs, DVRs, video game consoles, and smartwatches. You name it, smart fridges. Everyone is using Linux in the backend. And one of the biggest success of Linux outside of the operating systems is or the main operating system for PCs is the Android operating system, right? The Android is completely based on Linux, and it is one of the most used operating system apart from the Apple's iOS. And of course, Apple doesn't claim it, but they must have taken a lot of things from Linux as well to create the iOS. Of course, they are not going to claim to actually accept that or agree with that statement. Same as Microsoft. Microsoft hides a lot of things behind the registries and GUI, but internally they must have taken a lot and lots of things from Unix and Linux, right? So if you see the timeline, Unix was basically the father of all the operating systems, which was created in C language, mother of all the languages. So back in 1969, Unix was created. And before the Linux was created, you can see in 1981, MS-DOS was released. 1984, Apple System 1 was released. And then in 1991, that's when the revolution happened. The Linux was released and quickly became very, very popular. And the Mac OS, which is the modified version of Apple system, was released in 2001. So you can see that from 1991 onward, there have been many different distributions or different implementation of Linux using the Linux kernel. Because you can't use just the Linux kernel, right? You need a shell around it so that you can start giving some user interface. So the user can start using it. Even if it is CLI, you need some user interface so that you can get the instructions from the user in the form of commands or clicking on in the GUI, and then you can convert those instructions into the Linux low-level language that the kernel can actually understand, right? So there are different distributions which have been out there. So you will see that it is basically the Linux kernel, which is packaged into these one of these distribution. And distribution basically creates the outer layer of the operating system, including what kind of package management you are going to use to implement Linux or install Linux. So this is an operating system that is made up of a collection of softwares based on the Linux kernel. So all the softwares that you install, that they will also depend on what distro you are using. Some softwares might be supported or packages supported in one distro, but not in the other. But some of the core packages will be supported in all distros because they directly communicate with the Linux kernel. For example, KVM, just like we use VMware workstation on a Windows machine, or we use Oracle's VirtualBox on a Windows machine. These are type 2 hypervisors, right? Because they need to interact with the operating system, and the operating system then interact with the kernel. But in Linux, we have a virtualization engine hypervisor type 1, which is called KVM, kernel virtualization machine and or module, which actually directly interacts with the Linux kernel, cutting the operating system from the middle. And that's why KVM is very efficient hypervisor or very efficient virtualization tool that is used. As a matter of fact, EVNG that we use, EVNG is also nothing but a KVM in the Linux operating system. So you can also say that these distros contain the Linux kernel and the supporting libraries and softwares around it. Now remember, the softwares in Linux are called binaries. They are called executable binaries, and the libraries are actually the supporting code for the binaries. So libraries, you can think of that there are some part of the code which is used again and again and again by many different programs. So instead of using that code or copying that code into all the programs, which will be basically duplicated, you can keep it into a library, and that library can be called by all these softwares who want to execute that piece of the code. So libraries are basically shared code between different softwares or different binaries that you can have into the Linux operating system. So that of course begs the question that how many different types of Linux distributions are out there. So you will see that there are, as I mentioned earlier, there are more than 1,000 Linux distributions which are active, and there are so many different very task-specific distributions. Some very general, some very user-friendly, some are extremely non-user friendly, very difficult. So we can actually divide them into different types. Like there are core distros, which were created initially, and then other distros actually based on these core distros. For example, Debian is one of the core distros. It was created very early, and Red Hat is one of the core distros. But if you think about Ubuntu, Ubuntu is created based on the Debian, one of the Debian's branch. On the other hand, if you think about Fedora, it is created based on the Red Hat Enterprise original Linux, right? So if you think Linux Mint, it is based on the Debian or Ubuntu as well. So the core distros were created directly based on the Linux kernel, and then there are other specialized distros which have some certain specific requirement, and they will be dependent on one of the core tree, Debian based or Red Hat based, right? And these specialized distros can be used for different purpose. For example, there's Gentoo Linux, which is used for mostly for networking modules, and there are many other Linux which are created only for particular purpose in mind. And then if you are just looking to experience the Linux without installing it on your hard disk drive, there are live CD distros as well, where you can directly uh, use the CD or USB and directly run the Linux operating system from the USB stick or from the CD or DVD drive, and not installing it on your machine until unless you are comfortable. You say, now I think I can use this one. This was a good one. So then you can decide to install it on your hard disk drive. So some of the major distros that we should be aware of and we should know is Ubuntu, Linux Mint, and MX Linux. These are considered the easiest basically for the new users. So if you're a new user, completely new user, and you are scared that I don't want to go away from Windows experience because it is highly GUI Windows experience, so you can actually go with the Linux Mint or Pop OS, MX Linux, Ubuntu. These are very similar to the GUI experience you guys get into the Windows machines. On the completely opposite side of this, Arch Linux, Gentoo, and Slackware Linux, these are advanced distros which need comprehensive knowledge of Linux before they can be used effectively. Uh, Many times people jokingly say that if you use Arch Linux if you really hate your life, because every time something will be broken in a new release cycle and you will need to spend hours to troubleshoot it and fix it. Of course, you come out as a Linux pro after that because you have to deal with so many issues and you had to do so much research, you have to fix it so many times that you become extremely proficient. But of course, this is something for the advanced user. So if you're a new user and you don't want to run away from Linux, don't try to use this at the initial stage. And then, of course, you have somewhere in the middle some medium level operating systems like OpenSUSE, Fedora, RHEL, and Debian. These can be considered mid-level distros because they are slightly more difficult or slightly less user friendly, I would say, compared to Linux Mint or MX Linux, but not as bad as Arch Linux or Slackware. And there is a slight learning curve to these, right? And that's why you need some basic Linux introduction to start using them properly. Right. So more specifically, if we talk about the Linux distros, the Debian one is with the very one of the oldest Linux distribution. It was developed in 1993, and this was done by completely volunteers. Right, there were developers around 1,000 developers, and they created around 50,000 different packages or binary softwares for Debian, and that's how it started becoming popular. So, of course, as I mentioned, this is one of the main trees, right, of distros. Like many other distributions depend on the Debian-based implementation. So they inspired more than 100 Debian-based Linux distributions and lives. There are actually two main or three main branches in Debian. There is one unstable SID branch, and there is a testing branch, and then there is a stable branch. So unstable branch is like the hotbed of all kind of testing and checking new things. And sometimes things break, sometimes it doesn't come up again, or it doesn't work at all, and you have to do it right from the scratch. And then there are some testing implementation of these branches where it is more stable than unstable branch, but still you are testing things, but it's better than unstable branch. And the stable branch is using only the packages which have been tested and tried, and they are not breaking anything, and you can use them into a very stable implementation. For example, Ubuntu is based on the unstable branch of the Debian, the SID branch of the Debian, and that's why Ubuntu is like also a center of doing a lot of testing and trying new things. But Debian on its own, you will see it's a very stable one, and you get the high level of quality control in this one, and supports actually more processor architectures than any other Linux distribution. That is one of the strong points of Debian. So if you are using AMD or Intel based or ARM based architecture, then you know that Debian will support it, and more new architectures are also supported by Debian. Uh, the one of the issue with Debian is that newer technologies are not always included, and there is always a slow release cycle. Because remember, Debian is aimed for the servers. So on the servers, you are not actually looking for the latest feature or the new technology as soon as possible. You want stability, and that's where it shines, right? Of course, the second branch is actually Red Hat, where the Fedora was introduced back in 2004, but formerly known as Red Hat Linux, and origin actually dates back to 1995. So it has also been around, But the name Fedora has started being used from 2004, and they introduced the revolutionary RPM package management with dependency resolution and other advanced features. So what used to happen before in Linux, that if you wanted to install a software or a package, it might depend on some other packages to be already installed. So if those other packages are already not installed, this new package will not install. So it has dependencies that you need to resolve. And once you have all the dependencies resolved, then this package can be installed. So that was a big issue before RPM. But RPM actually introduced the concept of dependency resolution. That means it can automatically find out what other packages will be needed by this package, and it will install all the required packages as part of the installation. So they call it the high level package manager or package management system, because all the dependencies can be resolved automatically. That was a big innovation. That was a big change into the Linux implementation. Made it very popular because of that. And it's highly innovative. In Fedora, you will see there's always new features they are testing and implementing, and it has outstanding security features because it actually supports the SE Linux, security enhanced Linux, and many other features are supported. And new features, they are not actually shy away from, they don't shy away from checking new things as well. And it has a large number of supported packages, and it is keep on growing because this is the test bed basically for for the Red Hat Enterprise Linux and CentOS stream. Other Linux store that we are going to concentrate in this course is the Red Hat Enterprise Linux, or RHEL. So this is basically the downstream distribution of Fedora and CentOS. So as I mentioned that you check many features in Fedora, and then only the comparatively stable ones go to CentOS stream, and then the most stable one make it to the Red Hat Enterprise Linux, which is the enterprise version or official version from Red Hat organization, which they actually provide support, long time support for this. Commercially backed and supported, and support is generally for 10 years or more. So that's why they charge you. They are not charging you for the operating system, they're charging you for the support and the technical resolution of your queries. Although a free developer license is available, as I mentioned, for testing and small office, home office implementation. But this one also, you have to register the device online, free of course, or you need to disable the subscription manager, delete the subscription manager to start using it without any registration. So for package management, it uses the RPM based DNF utility, which used to be called earlier yum utility, yum install command, but now it is DNF install or DNF command as the package manager. And that is the one that we are going to use in our implementation that we are going to start from the next week. So next week, I'm going to install Rocky Linux or Red Hat Enterprise Linux. We'll see that which one we can do. And then we'll see that what are the things that we need to consider when you install, what are the partition schemes you need to know about, directories information, and the file system implementation or file system information that we are going to cover. So that's it for today. I just wanted to introduce the course structure and what exactly we are going to cover starting from next week. So about myself, you already know. I have been in training business for a long time, so I think we can skip this part.
Yeah.
So yeah, that's it from my side. So Lee, I think next week also you can install it again with the new information that I'll give you.
Yeah.
But if you already have the Linux setup, you can use this one for the basic command that we will start later after that.
Okay, no problem. That's great.
Right? So I'll send you this file, although you do have all the links and everything, but just in case you want to keep it with you,
Yeah.
the Linux links to download Linux OS, and this PPT, which has some basic information about Linux introduction, right?
Yeah, that'll be good. That'll be good. Thank you.
All right, so I'll see you next week. Thanks, Lee.
Speak next
Have a
week.
good
Cheers,
day and
bye
good
bye.
week.
You too. Bye bye.
Bye bye.
Bye.